if you ask me, Jakob, choose just one topic of all the interesting topics in the history and philosophy of science, I'd say the problem of demarcation between science and non-science would be my favorite topic. And just like last week, we're going to come across a case when philosophers not only debate the right answer, they also debate as to which one of the questions needs to be addressed. This is what happens quite often in philosophy. That's why you have different schools of philosophy, which differ not only in their answers, but also in the questions that they try to tackle. First things first. The general question is, what is the difference between science and non-science? If you analyze the literature, the available literature on the topic, you will see that more often than not, the question that they actually discuss is one concerning scientific theories. So the question that they actually discuss is, what are the characteristics of a scientific theory? Let's take a bunch of theories. General relativity. What's this? Can anyone guess? Okay, that's witchcraft. And the idea of witchcraft is that, allied with the devil, witches employ the magical powers and spells to harm innocent people. And here on this medieval drawing, we see 3 witches here being treated in an orderly fashion, being burned, I mean. Here we have history, alchemy, genetics. What's this?
Medicine.
Yeah, but what kind of medicine? Homeopathy, exactly, that's what it is. And the key idea is that a substance that causes a disease in healthy people can cure the disease in sick people. Like cures like. Neurophysiology, what's this? Tarot cards. What do they do? What's their use? And the general name for the whole enterprise would be divination. An insight into a question can be gained by means of reading signs and omens, all through contact with a supernatural agency. The good thing about this whole enterprise of divination, you actually get to choose your medium. You can choose a crystal ball, or you can choose a set of runes, or tarot cards. Well, as long as you pay the money, who cares, right? Now, we have creationism, we have Newtonian physics, superstring theory, astrology. Which of these theories are scientific and which are not scientific? The first thing I want to ask you to do is to listen to your gut feeling. At this stage, we don't have any openly stated criteria. We don't have anything written down, okay? What I want you to do, we're going to go one by one, and you're going to tell me that this one is scientific, that one is not scientific. Let's have this experiment. So these are our scientific theories, and here on the right-hand side, we're going to have unscientific theories. What about general relativity? Science, yes or no? Yes? Yes. Yeah, okay, that's clear. What about witchcraft? No, clearly not a science. History? Yes, it is science. Well, some people say, what kind of science is it? Yes, it's a science. It doesn't want to formulate any general theories. The task of history is to understand how things happen. It could be natural history, when you say the Earth was created or was formed 4.5 billion years ago. This would be a proposition from natural history. Or it can be social history. You say Augustus was the first emperor of the Roman Empire. We believe that this is true, as much as we believe that the Earth is an oblate spheroid, isn't it? So we believe that history provides us with trustworthy knowledge, well, more or less. So it is science. What about alchemy? You think it's science?
No.
Oh, of course it's no. Genetics?
Yes.
Yes, obviously. What about this one? Homeopathy? No. It's a clear no. Neurophysiology? Yes. Divination? Anyone? No, of course not. Creationism? No, of course not. This one, Newtonian physics? Yes, it's science. Superstring theory? Yes. And finally, astrology? No. Okay. Would it be safe to say that when we trust our intuitions, we seem to arrive at the same conclusion, roughly? We may debate this or that, but in general, I think we have a clear idea as to what's science and what's not science. Would this be safe to assume? You've seen this. If you look at these theories here, you are going to notice that some scientific theories here are part of our contemporary scientific mosaic, just like that. Others here, the Newtonian physics and superstring theory, are scientific but unaccepted. This one is no longer accepted, and this one is not yet accepted. Maybe one day it will. So we have not two, but really three categories of theories. We have accepted scientific theories, unaccepted scientific theories, and we have unscientific theories. Unscientific should not be confused with unaccepted. It can be scientific, but unaccepted. Is this clear? Very good. Now, if you understand this, then the question immediately becomes, how do we distinguish between the two sets? What are the criteria of demarcation that allow us to draw the line between scientific and unscientific theories? I'm going to give you different versions, different attempts to explicate our intuitions, because we all seem to have the intuition. Now the task is, let's try and write it down. Let's try and make it explicit. I'm going to try to formulate our implicit criteria of demarcation explicitly. This is what I'm going to try and do. Okay? Attempt number one. An empirical theory is scientific if it is based on experience. Is this a correct explication of what we have in mind? What do you think? Miriam?
Hi. Lots of people have had experience with tarot cards and say that it worked for them. So that's experience that's not scientific.
That's very good. So in fact, there can be many theories which are seemingly based on experience but have nothing to do with science whatsoever. I'm going to give you a few examples. This one is my favorite from astrology. What about comets? It is customary in astrology to think that the appearance of a comet foreshadows a disaster. It can be anything, really. It could be a famine, a fire, war, plague, anything. And if you look at the history, look at the track record, it turns out that this is really true, or it appears to be. Let's have some confirming instances, shall we? The famous comet of 1066 foreshadowed a huge disaster in the history of England. Anyone knows why this year is important? Anyone?
The Battle of Hastings?
Exactly, the Battle of Hastings. As you can see, there's a comment and it says, Isti miran stella, which pretty much means that these guys are staring at the comet, or the star. And here we have King Harold II, who was actually killed here, you see, and William the Conqueror, the first Norman king, became the king of England. So Harold II was the last Anglo-Saxon king. And for 300 years after that, all of the English nobility, they spoke French, really. Battle of Hastings. So the comet of 1066 was followed by the Norman conquest of England. You see, foreshadowed as disaster. This one, 1456, was followed by a series of deadly earthquakes in Italy, central Italy, southern Italy. And finally, the comet of 1664. What did this one foreshadow? A year after that was the Great Plague of London. And a year after that, 1666, there was a Great Fire of London. Destroyed the city, and probably because of that, we have all this nice architecture of Christopher Wren. If you go to London, it's all built after that. So the comet of 1664 preceded the Great Plague and Great Fire of London. We summarize the experience and we arrive at this nice scientific theory that the appearance of a comet foreshadows a disaster. So is it safe to say that even this nonsensical theory is, in a sense, based on experience? All agree that any nonsense can be based on experience? So the problem here is that based on experience is extremely vague. It's so vague that it allows you to cherry pick your data. You have phenomena A and you have phenomena B, and you want to link phenomena A with phenomena B. In proper science, you have to show that the two are linked at all times. And here, you find those cases when they appear to be linked, where they appear to coincide. And then you say, oh, you see, there's a link there. But what about those thousands and thousands of other disasters that weren't foreshadowed by any comet whatsoever? What about those disasters? That's why based on experience is not really good. How about this one? I'm going to change this now. An empirical theory is scientific if it explains all the known facts of its domain. Would this be a good explication? What do you think? Does this ring any bells? Does this fit your intuition? Rob?
Many people might say that certain theistic theories aren't really scientific, but the thesis that God exists, for example, could explain every fact in the world.
That's a very good point. We're going to get to that. But can you think of a scientific theory that doesn't really explain all the facts of its domain?
Sure, there's evolutionary theory.
Exactly. It's safe to say any theory whatsoever. There's not a single scientific theory that explains all the facts of its domain, and we're going to have a look at that. Now, I'm going to take a timeline. 1740, this is the year when Newton's theory became accepted on the continent. It had been accepted before that in Britain, but this is the year when it became accepted universally, on the continent included. 1859, this is a very important year in the history of astronomy, because that's the year when astronomers discovered the anomaly of Mercury's perihelion, the advancement of Mercury's perihelion. This is what they discovered. So this is your planet Mercury, and this point here is the point of least distance, the Mercury and the Sun, the so-called perihelion, and the opposite here would be aphelion. Now, it is expected, according to the Newtonian theory, that the perihelion must advance. You see, with every revolution, it must slightly advance. However, the problem was that the actual rate of the advancement, the speed of the advancement, the so-called precession, disagreed from that predicted by Newton's theory. So if you took your Newton's theory, that was the accepted theory, we took that theory, made all the calculations, and it turned out that the actual rate of advancement is nothing like the one predicted by the theory. You see? So here we had a typical case of an anomaly. We had an anomaly, something that contradicts the predictions of the theory. We're going to zoom out. So precession of Mercury's perihelion. Another fact here is the elliptic trajectories of planets, and the third type of phenomenon is the unidirectional revolution of planets, the fact that all planets revolve in the same direction. Of these three different classes of phenomena, Newtonian physics successfully explained why planets have to revolve in ellipses. It did. This was successfully explained. For unidirectionality, for the phenomena that all planets revolve in the same direction, not only in elliptical orbits, but also in the same direction, for a very long time there was no explanation. It didn't contradict the theory. The theory allowed for that arrangement to exist, but there was nothing in the theory, or there appeared to be nothing in the theory, that really forced planets to move in the same direction. For a very long time, there was no explanation for this, you see? So it wasn't really an anomaly. It didn't contradict, and yet it remained unexplained. And then in addition, you had a serious anomaly. And yet it didn't refute the theory. It didn't lead to refutation, and the theory was only rejected after it was replaced by general relativity 60 years later. So what do you do with this? It's clearly, if you apply this, then many strictly scientific theories would immediately become unscientific. Therefore, you can't really apply this criterion. How would you modify this? There is some rational content in this, and yet this needs to be modified. How about this suggestion? How about this one? An empirical theory is scientific if it explains, by and large, the known facts of its domain, by and large. So we're choosing essentially an intermediate position between, cherry picking and explain everything. Explain everything is too idealistic, and if you allow cherry picking, then a whole bunch of nonsense is going to count as science. So we choose an intermediary position. Is this good? What do you think? I'm going to go back to what Rob suggested a few minutes ago and say this is not good because there are many unscientific theories that explain everything. Not by and large, just really everything. Astrology is the best example. How about we experiment a little bit? Let's take this cancer here. It's a famous cancer, Peter Griffin, and he happens to become a teacher. Well, this is very good because it is a common knowledge that cancers are born teachers. Let's say we are very good explainers. That's what they say about us. You see, I don't say that. It would be extremely modest of me to say that. So this would be very good because astrology can explain perfectly well why this cancer became a teacher. Very good. But what if he becomes a piano player? What about that? You think astrology would be refuted? No. They say, well, some of them become teachers, but not all of them, right? Because there's all this important influence by the secondary planets. There's Mercury and Venus and Mars and Jupiter and Saturn and whatnot. There's a whole bunch of things influencing the character. So it's not really surprising that this particular Cancer became a piano player. Very good. And then what about this one? This one became a drunk. I suppose for the sake of argument, we're talking about 3 different Cancers, not the same person. Do you think astrology would be refuted? They would say, we couldn't really expect this one. No. Is that what they would do? What do you think? They would probably say, upon further scrutiny, it turns out that the position of Mars was really disadvantageous. As a result of that, they had no other choice than to become a drunk. Right. So what's the problem here? And I think you know the problem. The idea is that post hoc explanations are always possible. Everyone can be smart after the fact. And this is the classical example of that. So if you want to make sure that your theory explains everything, there is a universal recipe for that. And the recipe is make your predictions so vague that the theory will hold, come what may. This is the wise man's position, you see? Say, well, I believe that tomorrow it will either rain or it won't. Or alternatively, this is a position of a politician. Say things in such a way that no matter what happens, you say, well, I told you exactly that. I said there is a 50% probability that the inflation will rise. Now, therefore, I think we can all agree that this is important, but this is not really sufficient, because even unscientific theories manage to explain the known facts. So how do we amend this? I think we can all agree that there must be something else that characterizes a proper scientific theory. And that thing, I believe, I might be wrong, but I think it's the idea that the scientific theory must be testable, essentially falsifiable. And by falsifiable, we mean that the predictions of the theory should be such that the opposite should be at least conceivable. A scientific theory should be able to say that in such and such circumstances, such and such things are possible and such things are not possible. So if you take any scientific theory, let's take basic scientific theory that says, if you let this go, it's going to go down. What does it really say? It says that it's not going to go to your right, it's not going to go left, it's not going to fly away, it's not going to spontaneously combust. This is what the theory says. It excludes options. Therefore, scientific theories must exclude certain options. If your theory is such that it doesn't exclude anything, it's not really science, is it? You see the point here? So what any good scientific theory does, it predicts certain things. And by making these predictions precise, it takes risks. The moment you take a risk, you can succeed or you can fail. But you're taking a risk, and by taking that risk, you're being scientific. This is what I think we nowadays have in mind when we evaluate our scientific theories. I'm going to give you a classical example here, superstring theory. Many philosophers have argued that this is not really science because it cannot be tested. Yes, they are right that at the moment it cannot be tested because there are technological limitations. But I think we can all agree that the theory is testable in principle. There's an important difference. It's one thing that the theory hasn't been tested or cannot be tested at the moment because we have huge technological limitations. It's another thing to say that the theory is testable in principle, meaning that we can conceive of a situation when we can test it. And I'm going to give you a few of the predictions of the theory, predictions of novel phenomena hitherto unobserved. One of those phenomena is the so-called micro black holes. Very, very, very tiny, not just like those huge black holes in the centers of galaxies. This should be extremely tiny. Hasn't been observed yet, hasn't been confirmed, but this is a prediction that can in principle be tested, you see? Another prediction is the so-called SUSY particles. The idea is that for every particle in the Standard Model, there must exist a supersymmetric partner particle. Forget about supersymmetric partner, whatever that means. As you can imagine, none of these particles have been observed so far. But again, this is a prediction. The theory takes risks. The problem with these predictions is that testing of these predictions requires energies that are not really attainable in current particle accelerators. We just don't have those energies required to test these predictions. So what we have here, we have a theory that makes predictions. These predictions cannot be tested at the moment. But are they testable in principle? Yes, they are. Given certain development of technology, they might become testable. And this is what's important. Not the fact of actual tests. They may or may not be available. But the fact that the theory makes bold predictions such that can be tested, at least in principle. Is this clear? Very good. If we all agree on this, then I think we can say that we have a more or less correct explication of our current criteria of demarcation. One thing we have to keep in mind is that this explication is just a historical hypothesis. We may or may not be correct, because essentially what we're trying to do here, we're trying to openly formulate our gut feelings, really, our intuitions. And by doing that, we are formulating a hypothesis concerning our gut feelings. Essentially, that's what we're doing here. So we may or may not be correct. Put this question aside, whether this is correct or not. Can we all agree that regardless of whether this explication of our criteria of demarcation is correct, we must remember that these are only our contemporary demarcation criteria? Let's not forget about that. These are only our demarcation criteria these days. If you were to go back in time 400 years ago and had a look at the Aristotelian criteria of demarcation, you'd immediately notice that their idea of science had very, very little in common with our idea of science. So for those guys, a theory was considered scientific if it at least attempted to uncover the nature of a thing. Thus, all accepted empirical theories of the time, if you pay attention, they attempted to grasp the nature of things in their respective domain. Let's say optics was supposed to grasp the nature of vision, natural history or biology is supposed to grasp the nature of biological organisms, so on and so forth. Every empirical theory was supposed to unearth the nature, because they believe that everything has a fundamental quality. Remember that. Things have their natures. So it was the task of science to unearth, uncover these natures. Mechanics, on the other hand, mechanics, the study of mechanisms, it wasn't considered science. For a very long time, they believed this is not really science, because there was no attempt to understand the nature of the object under scrutiny. You'd say, well, mechanics? Nowadays, we consider it part of physics, right? It's part of physics these days. Back in the day, it was considered something foreign to physics. Physics was the study of physical bodies and their natures. It was the task of a physicist to understand why things are the way they are. Mechanics, on the other hand, was a study of artificial mechanisms. Just here we have on this picture a typical diagram of an escapement from the 13th century. They believed that everything that is made by human beings doesn't really have a nature, because it's just an artificial tool. There is no nature to study. You created the thing. So if you say, well, I have this science, the task of which is to unearth the nature of ships, and say, well, ships are built by human beings. Well, they don't have any nature. They're artificial instruments. They're tools. They're artifacts. They don't have nature. So you cannot have science about that, you see? And by doing that, they turn the enterprise into craft, not science, really. You see the point? Now, alchemy, on the other hand, it was attempting to grasp the nature of things. It was attempting to understand why things are the way they are. Everyone knows what alchemy is? What is alchemy?
Turning elements into gold.
Not elements, really, because there were 4 elements, and they didn't believe that you can turn elements into gold, but they certainly believe that you can turn something into gold. Base metals turn into gold. Take lead, for instance, and you turn it into gold. Another one of their goals was the famous elixir of life, a potion or drink that was supposed to cure people and even, ideally, grant them eternal life. Other ideas such as elixir of love, again a potion that you give per person and she falls madly in love with you. There's a famous opera, one of my favorites, by Gaetano Donizetti, Elixir d'amore, Elixir of Love. Very good opera. Anyways, I digress. We're going to cut that, I assume. So although it wasn't accepted, you see, it wasn't taught in any of the universities, it was considered scientific. It was considered science. So you ask people, they say, well, it's a science, a failed one. They hadn't been able, to come up with anything worthy of consideration, but it's a science. It's a scientific enterprise. Now, let's agree that many once accepted theories are nowadays considered unscientific or pseudoscientific. Astrology, theology. How do you reconcile this with the idea that we seem to have some demarcation criteria, and yet if we apply this demarcation criteria to the theories of the past, if we apply our contemporary demarcation criteria to the theories of the past, then many of those theories, which were part of their scientific mosaics, will turn out to be unscientific by our current standards. So what do you do here? Up until the 1970s, I'd say, it was very popular among philosophers to say, well, that is because the real science originated only in the 17th century. The Aristotelian science is not real science. They didn't really predict anything. They didn't do experiments. What sort of science is that? It's not really science. The real science, originated in the 17th century. Some philosophers made a step further, and they said that the real science began only with the acceptance of Newton's theory. So even the Cartesian science wouldn't really count as science. The real science only would begin sometime towards the end of the 17th century, the early 18th century. Is this a good solution, my dear friends? What do you think? We have contemporary criteria of demarcation. We apply them. That's fine. Who cares about the science of the past? Is this a good solution? If we dismiss the past science as not really scientific, then we have to be prepared that 200 years or maybe 500 years from now, the scientists of the future will dismiss our contemporary science as not really scientific. So if we decide to dismiss all the past science the moment we switch our method, the moment something happens to our scientific method, this is a very silly thing to do. Think about this possible scenario. Suppose someone came up with the idea that somewhere in the faraway corner of the universe there exist so-called, let's call them orange holes as opposed to black holes. Let's call them orange for the sake of argument. And these orange holes contain all the information about everything in the universe, that somehow the information gathers there and gets collected. Now, suppose for the sake of argument, the theory says that these orange holes allow investigators to ask questions in such a way that no matter what is asked, the answer is always 100% correct. Because essentially what you get is a portal of knowledge. That's what they are, the orange holes. So as a scientist, the only thing you're really supposed to do is to build a spaceship, go and find one, ask all the questions about, life, universe, and everything, and then just get the answers, write them down, end of the story. Why would you need confirmed null predictions for that? Now you say, well, that's a rubbish theory. Yeah, it is a rubbish theory, but what if one of the predictions of this theory became confirmed? Our method of the time is hypothetical deductive, and this theory, in order to become accepted, would need some confirmed null predictions, wouldn't it? Suppose for the sake of argument that they were confirmed null predictions. Let's say 10 of them to be safe. The moment this theory becomes established, what's going to happen to our scientific method? By the third law, the scientific method will change. You understand that? From then on, experimenting with confirmed null predictions still would be okay, but it would be just waste of time, wouldn't it? You have a portal of knowledge, just go there and ask. Why do you need your particle accelerator? Why so much money? What's the point? Just go there and ask. And you go and ask everything about future, about the past, and you see, well, it actually works. It knows everything. Everything that we know and everything that we don't know, it knows everything. Would our method of science change? It would. We would put the hypothetical deductive method aside because we would have something infallible, really, something that gives us secure knowledge. And scientists of that time would look back and say, Einstein, Newton. No, those weren't scientists. The science begins now. That's when it begins, really. You see the risk here? So we should understand that the science of the past is not to be dismissed. So what do? You have to concede that the criteria of demarcation are changeable. They are changeable for two reasons. It's a historical fact that they have changed. We've seen this. You analyze the history and you see that. But in addition to the historical argument, there is also a theoretical reason why we believe that the criteria of demarcation are changeable. There's a theoretical reason. Recall this diagram. Method, any method, consists of three different components. Acceptance criteria, which are employed to tell whether a theory is acceptable or not. Then we also had the compatibility criteria. These criteria were employed to tell whether any two theories are compatible within the same mosaic. And you remember what the third component was? Demarcation criteria. These are the criteria that scientists employ to tell whether the theory is scientific or not. Therefore, we have to concede that since methods of science are changeable, demarcation criteria are also changeable. Can we all agree on this? Just by virtue of the fact that demarcation criteria are just part of the method of the time. Is this clear? Can we all agree on this? Oh, that's a confirmation. Now, there are no universal and fixed criteria for demarcating scientific theories from non-scientific theories. The criteria of demarcation employed 400 years ago have little in common with the criteria that we employ today. And that is the reason why a theory may be considered scientific at one period of history, just like theology here, and unscientific at another period of history. So if the criteria of demarcation between scientific and unscientific theories are changeable, the question becomes, is there really anything that characterizes sciences of different time periods? It certainly cannot be anything that has to do with theories. The moment you think about theories, you realize, no, the same theory can be considered scientific in one time period and unscientific in another time period. So the question remains open. What is it that distinguishes science from non-science? I know you're puzzled here, and you have to be at this stage. I want you to be puzzled. So what is it that distinguishes science from non-science? To answer this question, we have to switch from theories to the process of changes in the mosaic, to the process itself. So if your question is, what makes a theory scientific? I'm afraid I cannot give you a universal answer because the criteria of demarcation change through time. I cannot give you a universal answer. If you want to get a universal answer, you have to change the question itself. And the question is going to become, what are the characteristics of the process of scientific change? So it's the changes, transitions from one state of a mosaic to the next, from one theory to the next, from one method to the next, that may or may not be scientific. And here, I believe, we have a universal tool that tells us which changes are scientific and which ones are not. What is the tool? You can guess my answer. The laws of scientific change. The first law, the second law, the third law, the zeroth law. My idea is that any actual or potential violation of the laws of scientific change is usually qualified as unscientific. When there is a potential of a violation of any of these laws, we intuitively say, well, that would be an unscientific step to take. Or if we analyze the history of science and we come across an episode that actually violated any one of these laws, we normally say, that wasn't a scientific thing to do, was it? I'm going to give you 4 examples, one for each of the 4 laws. Imagine a mosaic, some parts of which are only preserved in a hefty manuscript, and none of the living members of the community knows them by heart. I do not argue that we've ever had such a mosaic. It's a weird mosaic. So you have astrology, you have Tychonic astronomy, you have homeopathy, divination, witchcraft, Platonic physics, physics of 5 Platonic solids, and Platonic metaphysics. I cannot think of any community that ever subscribed to this. That's not important. Imagine a mosaic that is only preserved in this manuscript. And suppose also that there exists exactly one copy of this manuscript. Because for whatever mysterious reason, the members of the community are not really allowed to make copies of this manuscript. Can you imagine this? Very good. Now, what would happen if the manuscript were stolen or destroyed or lost? What would happen? The consequences would be disastrous, wouldn't it? In a sense that at least some parts of the mosaic would be lost forever, because nobody knows them by heart, nobody knows everything, as we said in the beginning. So the consequences would be disastrous. They would lose their astronomy, more importantly, divination and witchcraft. By the first law, we know that the theories stay in the mosaic unless they're replaced by some other theories. This is what the first law tells us. And yet in this case, you would have a typical example of theories being replaced by nothing, lost forever. Would this be an unscientific thing? This would be. This would violate the first law of scientific change, for many theories would be rejected without any replacement. And essentially, this would be a violation of the first law. Forget about this imaginary community. You can imagine a contemporary community. Suppose a huge asteroid, oh, God forbid, but suppose for the sake of argument, hits the Earth, and most of the knowledge that's preserved in one way or the other gets lost. Scientists die, and the whole communities of people die. And that would be a violation of the first law. You had a scientific community, and then something happened, and then knowledge no longer preserved. So this would be a violation of the principle of scientific inertia. Is this clear? Let's take another example. 1940s. Normally, when I choose years, you have to be extremely cautious. Sometimes it indicates an exact year, but most of the time it indicates a decade or years around it. So the 1940s, the 30s and 40s, these were the years of Stalinist persecutions of the members of the scientific community. And these persecutions, for political reasons mostly, they reshaped the scientific mosaic in the Soviet Union. I'm going to give you a very famous example. So theories, methods. At the time, there was a contender theory, the so-called soft inheritance theory, that said that physiological changes acquired over the life of an organism can be transmitted to offspring. So those changes that you acquire during your lifetime, let's say you work out really, really hard, these changes can be transmitted to offspring. This was the theory available on the market, but this wasn't the accepted theory. The accepted theory of heredity was the so-called hard inheritance theory. And this theory says that physiological changes acquired over the life of an organism cannot be transmitted to offspring. So no matter how hard and how much you work out, the result may still be like that. There's still a chance that you're going to have a son of whom they say that he curves the space-time continuum around you. Right? Now, this theory, luckily for the champions of this theory, was supported by Stalin's regime. It was an important thing in this theory, the idea that if you work hard, if you change yourself, you can thus change the future generations. Very Marxist idea, very progressive idea. Because what's the point of working hard and making yourself a better man if it's not going to transmit to your offspring, right? What's the point? So it was, for ideological reasons, it was important to somehow squeeze this theory into the mosaic. The main champion of this theory was Lysenko, and he was supported by Stalin's regime. The method of the time was hypothetical deductive, as we can all imagine. So by the second law, in order to get into the mosaic, a theory of such boldness would be expected to have at least some confirmed novel predictions, wouldn't it? Right? It didn't have any. It didn't have a single confirmed novel prediction. And yet, it was squeezed into the mosaic, pushed in with a hammer. How did they do it? That's very simple. You just prosecute people who disagree, really. You just eliminate those members of the scientific community who dare to say no. That's exactly what they did. They persecuted the main geneticist of the time, named Vavilov. It wasn't alone. It became accepted because many members of the scientific community were physically eliminated. They were. We consider this case unscientific and also immoral, really, but also unscientific. Because here, a theory gets into the mosaic without having actually satisfied the requirements of the method of the time. So you had a community. What do? You just eliminate some of the members, convince those who are clever, really, who understand that they have to collaborate with the regime, otherwise the destiny is obvious, and there you have it. And you all know that this wasn't the first time things like this happened. Now, when you look back at this case, yeah, it's morally revolting, but also it's not really scientific if you think about it. Even if you don't kill people, just, even if you force them to change their beliefs, that still would be an unscientific thing to do, wouldn't it? Do you have that intuition? Do you all believe that this is not really a scientific thing to do? Can we all agree on this? Now, scientifically speaking, from the viewpoint of the theory of scientific change, this transition was not scientific because it violated the second law of scientific change. Is this clear? Yeah, another confirmation. So the case was a violation of the second law. Consider another case. Homeopathy, another one of my favorites. If you go to all these different websites on homeopathy, how is it that they try to convince their future clients, their patients, by the testimonials of the former patients? Let's analyze this case. Homeopathy, not part of the scientific mosaic, merely a contender, strictly speaking. All agree? Not part of the scientific mosaic. The idea is that a substance that causes disease in healthy people can cure the disease in sick people if properly applied. There are techniques. Like cures like. According to our current methods that's supposed to be assessing these things, evaluating these things, it's the double-blind trial method. The acceptance of homeopathic medicine must be tested in double-blind trials. Thus, you need two groups of patients suffering from the condition, statistically equivalent, more or less, such that the patients don't know which group they belong to. That's single blind. And in addition to that, the researchers who are in immediate contact with patients should also not know which group is which. So this gives you double blind. All agree? This is how we think these things must be tested these days. Very good. But if you ask homeopathic practitioners, almost all the time, the answer is something along these lines. Look at the testimonials. And you read and read and read all people's support. So basically what they do, they try to convince us to rely on the method of testimonials. This is what they're trying to do. They try to change the method. They're not trying to squeeze their theory into the mosaic. No, they first try to convince us that the method of testimonials is something to deal with, that it's a good method of assessment of these things. Exactly what they're trying to do. So what is the method of testimonials? If we explicate it, it would be something along these lines. A hypothesis about a drug's efficacy is acceptable if the drug's effect has been confirmed by patient testimonials. More or less, this is what the method is. For the homeopathic strategy to work, the method of testimonials would have to replace in the mosaic the double-blind trial method. Thus, but in order to become employed by the third law, it has to deductively follow from the theories that we accept, doesn't it? But does it? Does it follow from the theories that we accept? What would happen in this situation? Danny?
If we use the method of testimonials, the results will be quite skewed due to a bunch of exogenous factors, such as maybe the placebo effect, where the patient just thinks that he'll get better because he's getting treatment.
Exactly. This method, not only does it not follow from our accepted theories, it clearly contradicts some of our accepted beliefs, in particular the idea of placebo effect. We know nowadays that improvement in medical condition can have nothing to do with the therapeutic efficacy of the drug itself, but can be due to some physio-psychological factors. It contradicts that, and also contradicts the idea of unaccounted effects. What if the improvement had nothing to do with the drug itself? It had to do with improved nutrition or improvement in climate or body's natural healing ability, right? So essentially, if we were to employ this method, it would be a violation of the third law. It would be a method that became employed without being a deductive consequence of the accepted theories and other methods. You see, it would violate the third law. The case of homeopathy is qualified as unscientific because, among other things, it defies the third law. A case can be made that it also defies the second law, or it defies the zeroth law. So this is a multi-dimensional case, in a sense. A case can be made that you have multiple violations here. Any questions about this situation? Yeah, we have a question.
My name's Kareem. Perhaps the method of testimonials is also unscientific because it could perhaps cherry pick certain evidence from certain testimonials to support the claim that homeopathy works.
Exactly. If we try to create a list of things that are wrong with this approach, it would go on forever. So that's one of them. Because this method really allows you to cherry pick. You go on a website, you have 20 people who sincerely confess that it helped them. What about those 20,000 who didn't confess in anything, or who did confess but whose confessions were quite consciously removed by the moderator? This is clear, I hope, that we deal with an unscientific case here, and you understand the reason. Very good. Case number 4, again my favorite, astrology. Astrologers, even to this day, they still insist that celestial configurations they somehow influence terrestrial effects. It has to be said that not many practicing astrologers actually believe in this, because many of them understand, it's just useful, it makes money, you know. And yet there are some of them who still insist that configuration of celestial bodies somehow influence terrestrial effects. We have astrology here. What would happen if astrology became accepted? What do you think? What would happen? Forget about the method of the time. Suppose it somehow became accepted. So I don't want you to focus on the second law or on the third law. If it became accepted, it would introduce incompatibility into the mosaic. This is how. This here is the key premise of astrology. It's the idea that planets and stars have significant influence on human mentality and behavior. If you take quantum physics, if you take general relativity, these are the accepted theories, the two fundamental theories of physics. It follows from this theory that measured from the Earth, gravitational, magnetic, and other effects of distant planets and stars are almost negligible. Almost negligible. In a sense that even our electronics, household electronics, have far more significant effect on the human body and brain than distant planets and stars. So if we were to take into account the magnetic, gravitational, and other effects at the time of birth, we would have to study the arrangement of electronics, the place of birth. That would make more sense, really. You know, you're a cancer because the fridge was removed from the TV at a given distance, right? This would make more sense given our current theories. Unless there is some unknown force, we're all fallibilists when we understand we cannot give you 100% guarantee that it doesn't happen. But as far as the contemporary science is concerned, I think we can all agree that it just doesn't make any sense. Therefore, the planets and stars cannot exert any significant influence on human mentality and behavior. This proposition is implicit in our contemporary mosaic. We may or may not openly formulate it, and yet we can all agree that this is something we take for granted, because that's what follows from our physics. So here you see a clear case of incompatibility. If astrology somehow became accepted, there would be incompatibilities in the mosaic. All agree? The acceptance of astrology would be an unscientific move, for among other things, it would violate the zeroth law. Let's sum it up. The case of the lost manuscript was a violation of the first law. The case of Lysenkoism was a violation of the second law. Homeopathic reliance on individual testimonials is a violation of the third law. And finally, if we were to squeeze astrology into the current mosaic, it would lead to the violation of the zeroth law. Essentially, the idea is that any actual or potential violation of the laws of scientific change is usually qualified as unscientific. So if you're a historian, you delve into a history of science, you find a case which your gut feeling tells you that this is not really science. I think it is possible to reconstruct that case in such a way that any time you see something unscientific, it is because at least one of the laws of scientific change was violated. All right, so this is the idea. Now let's sum it up. We started with this general question. It is very general and it is very vague. As anything general, it can be specified. It can be specified differently. Traditionally, it is specified by philosophers along these lines. What are the characteristics of a scientific theory? So if you ask philosophers, on the one hand, you seem to realize that if the question is how do you demarcate scientific theories from unscientific theories, the answer cannot be universal. But they don't really know what to do. My suggestion is to specify the question differently. Change our focus from theories, because you cannot have anything universal there, to changes in the mosaic. It's when you evaluate the changes that you can say that this change is scientific and that change is unscientific. And these criteria are timeless, universal. They apply to the science of the 21st century and to the science of 11th century equally. You see, because the laws of scientific change are universal. Now, this here is the symbol of specification. It's normally used in UML when you have an interface and a class that implements the interface. Now, forget about these technicalities. The idea is that these two questions are special cases of a more general question, meaning that the moment you answer this question, you also answer the more general question. It's just a way to specify things, make something vague more specific. Now, as we have established, the answer to the question on your left depends on the method employed at the time. There are no timeless criteria of demarcation of scientific and unscientific theories. And thus, this question doesn't have a universal transhistorical answer. If you're looking for one, you have to refer to this question. It is this question that has a transhistorical answer. And the answer is a modification of the mosaic is scientific if it is in accord with the laws of scientific change. Is this clear? Good? Have we solved the problem? Very good. I think we have. Very good. Next time, we're going to focus on the history of science. And we're going to start with the Aristotelian medieval worldview. Okay, thank you.